now that we've learned most of our differentiation rules, our derivative rules, as well as the product, quotient, and chain rule, we're going to be applying it to a different circumstance. So we have something called implicit differentiation, and this is going to allow us to compare rates in word problems. So we'll be able to look at, let's say, the rate at which water is draining from a tub as a function of the rate at which the height of the water is changing. So it's going to allow us to relate two quantities that are changing and to talk about their characteristics. So implicit differentiation, when does that occur? Well, up until now, we've been finding the derivative of y with respect to x. When we differentiate a y, I'll say an expression with y, we have to include a dy dx with the, we have to include a dy dx, or the derivative of y with respect to x, wherever we derive the y expression. So this might sound kind of funky, all right? And we've got some steps here that we're going to follow for these problems. All right, so make sure you write down those steps. But let's just think about our notation if I were to have just a basic derivative, right? We were saying that derivative of y with respect to x is equal to 2x here, using our power rule, right? The derivative of y is 1, right? Just like the derivative of x is 1. So we've got 1 dy dx here, or dy dx equals. In situations now, using implicit differentiation, we could have the following. So the derivative of this would be 2y, and since we did the derivative of a y expression, we have to include a dy dx equals 2x. Our steps are going to be having us isolate that dy dx on the, on the left-hand side and solving for it. So we'd cross that out, and we've got the derivative of y with respect to x equals 2x divided by 2y. So that's what we'll be doing. We're going to have more complicated y terms now. And when we do the differentiation of the entire equation, we're often going to end up with more than one derivative of y with respect to x. So we'll have to move all of those terms to the left, all terms without a dy dx to the right, and then factor out that derivative of y with respect to x before dividing both sides by the remaining factor. So let's look at a few examples. So this one, the derivative of y is 1 dy dx. Right. The derivative of cosine is negative sine. So we've got plus 6 sine y. And then we just did a derivative with a dy with a y, so we need to include a dy dx. And then over here we've got the derivative with just an x, so this is just going to be our normal derivative. We want to solve for dy dx. All of our dy dx terms are on the left, so we're just going to factor out. And since we want dy dx by itself, we're going to divide both sides by 1 plus 6 sine y. Right, this cancels, and we've got dy dx equals 2 secant squared x over 1 plus 6 sine y, and we call it a day. All right. So not the most complex of processes. The way it's going to get more complicated is we're going to have to use the chain rule for some problems, or the product rule and quotient rule. So within these examples in the I do section, we'll have a couple of chain rule problems. Within the examples that follow, we're going to have some product and quotient as well. So let's go ahead and look at number 2. Here we've got an outside and an inside, right? You'll notice we've got 2x, and then our outside being that 15 cotangent. So let's go ahead and set that up as we have been doing, right? We're talking about an outside and an inside here. So our outside being that cotangent, and then we left the g of x in there. And then we said g of x is equal to that 2x. We did the derivative of each of these. So derivative of the outside with the inside remaining the same is going to be equal to negative 15 cosecant squared x. And the derivative of the inside is going to be equal to 2. So we have our derivative of this mess is equal to the derivative of the outside with the inside remaining the same times the derivative of the inside. So we've got negative, I'm sorry, I made a mistake up here. This should be g of x. Negative 15, oof, just a hot mess this morning. Cosecant squared 2x, because that's what g of x is, times g prime of x 2. Negative 30 cosecant squared 2x. So now that we've got that, when we go back to our original equation, the derivative of that left-hand side is negative 30 cosecant squared 2x. And then we just keep going down the line with our normal derivation. So the derivative of 16y is going to be negative 16 dy dx. Because we're doing a derivative with a y expression, we need to include the dy dx. Then we've got 120y, which is going to be 120 dy dx. Then we've got 5 as our exponent, so bring that down. We've got negative 23 times 5, y to the 4th dy dx. Let me just divide this off. So negative 30 cosecant squared 2x minus 16 dy dx equals, and then I've got 120 dy dx minus 23 times 5, which is 115 y to the 4th dy dx. Move all of our terms with dy dx to the left-hand side. And every term without dy dx to the right-hand side. All right, so our 30 cosecant squared cancels on that side. 120, 120, 115, 115, those cancel. We've got negative 16 and 120 dy dx, so those are like terms. We can combine those. So I've got 104 dy dx plus 115 y to the 4th dy dx equals 30 cosecant squared 2x. Factor out your dy dx. And we divide both sides by that variable expression. Those cancel, and we're left with dy dx equals this guy. All right, two more. So we'll look at them in order, I suppose. So I've got y minus 6, so the derivative of y is dy dx, minus the derivative of 6, which is 0, so we can just get rid of that guy. Remember, we were going to rewrite this with a fractional exponent. Whoopsie. And when you look at that, you're going to recognize that you've got a chain rule problem. So I'll just do that in blue over here. So I've got f of g of x, and that's going to be g of x to the 1/5. The derivative of that is 1/5 g of x to the 1/5 minus 1, or negative 4/5. Rewrite that, it's going to be 1/5 g of x. 4/5 becomes the 5th root of g of x to the 4th. And then we have the derivative of g of x with g of x equaling 3x squared minus 8. So the derivative of that guy is, pull down your exponent, so you get 2 times 3, 6x. We multiply these two. To get our answer. When you do that, you're going to end up with 6x over 5 times the 5th root of g of x to the 4th. G of x is 3x squared minus 8 to the 4th. All right, so we're going to go ahead and put that into our expression here, where we would have had 3x squared minus 8 to the 1/5. So that goes here. 6x over 5 times the 5th root of 3x squared minus 8 to the 1/5 to the 4th. All right, and then derivative of 2y is 2 dy dx. So the only term with dy dx that we have to move to the other side is that 2 dy dx. 1 dy dx minus 2 dy dx is negative dy dx. Put a 1 there just so it's clear what we're about to do. Right hand side stays that hot mess. All right, so we want to get rid of that negative 1. So if we divide the whole thing by negative 1, we've got dy dx equals negative 6x over that hot mess, 5th root of 3x squared minus 8 to the 4th. All right, next up. So we're going to rewrite this guy. Instead of x, 1 over x to the 5th, we've got x to the negative 5th. And we're ready to do our derivative. You'll notice this first one has an inside of 3y. So let's go ahead and do that chain rule. I'm just messing up my notation all over the place here. Bear with me. I promise we'll get it together in a second. All right, so derivative of the outside, the inside staying the same. 15 over g of x. Derivative of g of x, we have 3. We did the derivative with a y expression, so dy dx. The overall derivative is the derivative of the outside, the inside staying the same, times the derivative of the inside. So when you do that, you're going to have 3 times 15, or 45, over g, which was, what was 3y, times 3 dy dx. 3's cancel, so you've got 45 over y dy dx. All right, so now let's go down our line here. We've got 45 over y dy dx minus derivative of 16x is 16. X to the negative 5th is negative 5x to the negative 6 plus 20y, so dy dx, 20 dy dx. Move our terms. Let's see. Cancel, cancel. All right, no like terms on the right-hand side. No like terms on the right-hand side. I'm just going to rewrite that negative exponent on the denominator. All right, and then we're going to factor out, if it'll let me scroll, dy dx. We're going to be able to do some like denominator business here. All right, so it's going to get a little uglier before it gets better. So to get like denominator on the numerator, we want to be over x to the 6th. And to get like denominator on the denominator, we want to be over y. So we have dy dx is equal to negative 5 plus 16x squared. Oh, not squared. Yikes. X to the 6th over x to the 6th. And then we've got 45 minus 20y over y. When you divide fractions, multiply by the reciprocal. Nothing cancels here, so we're just gonna write them as one big happy family. Call it a day. All right, so that one had some algebra at the end there.